This is a nice problem regarding arithmetic and number theory. Here is the following information. We have x and n as a natural number and p as a prime. We have this following equation. We have x to the x plus number 1 equals p to the n. So our goal, we are going to find these triplets x, p and n. Let's go through this one to see what's given us. Let's take the first case if p is a even. If p is a even, which means x is a odd, okay? So x is a odd. Let's set x equals 2a plus number 1, okay? So which means x to the x equals 2 to the a, 2a plus number 1, all to the 2a plus number 1, okay? So I'm going to simplify this one a little bit. I get 2a plus number 1 factor 2a plus number 1 to the a, all is raised to the number 2 as a power. Let's set this term, which is this one, like z term, then take this value and transfer this equation in terms of z now. So I get here the following. I get x to the x, which is 2a plus number 1 is multiplied by z squared plus number 1 equals 2 to the n, okay? I have replaced p with number 2 as an even prime. Let's take this number 1 to the right. So I get here the equation becomes 2a plus number 1 z squared equals 2 to the n minus number 1, okay? Here is the thing. If n is an even, I will have the difference of two squares here, which means I'm going to transfer this one into the product. One of the terms of the product is plus, the other one is minus. If n is an odd, you will have a different factorization, okay? First of all, let's take this one. If n is an even, if n is an even, let's set n equals to m, okay? Which means this one is going to be on the form of 2m minus 1 factor 2m plus number 1, okay? Another thing here, GCD of this one equals 1 because both terms are consecutive odds, okay? Which means I'm going to write z with its value to make it more clear. So I get here 2a plus number 1 factor 2a plus number 1 to the a is multiplied by 2a plus number 1 to the a because we have a square here, okay? Equals 2 to the m minus number 1 factor 2 to the m plus number 1. The smallest value is going to take the smallest value from the left hand side of this equation, and the biggest value is going to take the biggest value. So now we are going to take a couple possibilities. The case number 1, since GCD equals 1, this number, it could be number 1, okay? So the case number 1, I will have 2 to the m minus number 1 is going to take number 1. The other one is taking the whole thing, okay? I will get 2 to the m plus number 1 equals 2a plus number 1 is multiplied by z squared. This is the first case. Let's take the case number 2. The case number 2, this one, it could be 2a plus number 1. So we'll have 2 to the m minus number 1 equals 2a plus number 1. So the other one is going to take the rest, which I get 2 to the m plus number 1 equals 2a plus number 1 to the a square, okay? Let's move on to the case number 3. 2 to the m minus 1, it could be 2a plus number 1 to the a, okay? The other one, which is 2 to the m plus number 1 equals 2a plus number 1 is multiplied by 2a plus number 1 to the a, like this, okay? So we still this one bigger than this one. Now let's go through each one. Let's go through the first one. First one, by taking the minus 1 to the right, I get here 2 to the m equals 2. Let's take this value and insert it into the second equation. Number 2 here plus number 1, which equals 3, equals 2a plus number 1 is multiplied by z squared, okay? Since 3 is a prime and this one is a odd, this one is a odd, Number 1 is going to take this one. Number 3 is going to take this one, because this square is bigger than 2a plus number 1. Okay, so one is telling us 2a plus number 1 is going to take number 1, which means a equals 0. Plug in a with 0 here, you get 0, number 1, 1 to the 0, which is 1, 1 square, which is 1, 0 here, 1 is multiplied by 1, which is 1. Back to this one, you get the same thing, 0, number 1, this number 1, you get number 1 here. You will have 1 plus 1, which is 2. 2 equals 2 to the n, which means n equals 1. So I have determined the first solution. X also equals 1, because x to the x equals to z, which is 1. X to the x equals 1, which means x equals 1. I get p equals 2 and n equals 1. So here is the first solution. Now let's move on to the second case, which is this one. Second case, I will have the same thing here. I put this equation minus this equation to get 2 to the m cancelled out. So we'll have number 2, 1 minus 1, which is 2. This one minus this one, I'm going to take 2a plus number 1 as a common factor. 2a plus number 1 as a common factor. This one will be multiplied by 2a plus number 1. Multiplied by e to the minus number 1 is multiplied by, I take 2a plus number 1 as a common factor. This one is going to multiply by 2a plus number 1 to the a minus number 1. So if I'm going back to this one, I get to this one. But we need to multiply another copy of this one, which is 2a plus number 1 to the a. Okay, so we have this one involving 3 products. Okay, we have this term is smaller than this term, is smaller than this term, but the whole thing equals number 2. This is impossible. This is odd is multiplied by odd is multiplied by odd, but this one is even, which is impossible, which means this case doesn't work. Let's move on to the next case. By doing almost the same job, this one minus this one, I get rid of 2 to the m, cancelled out. I will be left with 1 minus 1, which is 2. I will have the same thing here. This one minus this one, I'm going to take 2a plus number 1 to the a as a common factor. This one was multiplied by 2a plus number 1, but this one is multiplied by minus 1. Okay, I get number 1 cancelled out, minus 1. I will be left with this one. 2a is multiplied by this one. So I get here 2. I'm going to take number 2 as a common factor. I get a is multiplied by 2a plus number 1 to the a. Okay, I'm going to divide both sides by number 2. This one is taking us 1, is giving us 1 equals a is multiplied by 2a plus number 1 to the a. This is impossible. This one is bigger than this one, because which value you can give a to get number 1? There is no product it can give you number 1 for this one. Okay, because since we have this product, a equals 1, and also to a plus number 1 to the a equals 1. If a equals 1, let's replace number 1 with a. Let's replace a with number 1. I get 2 plus 1, which is 3, to the 1, which is 1. This is impossible. Okay, which means none of these cases works except first one. First one, which give us a solution. Okay, this is happening for only if p equals 2 as an even prime. Now let's move on to the next case where we can have p as an odd prime. Okay, from the last board we have built this solution for the p equals 2 as an even prime. Now in this case we are going to discuss when we have odd prime. So if p is an odd, which means x is an even, because even plus number 1 is given as odd. Okay, let's set x equals 2a. Okay, we have x to the x, which means x to the x is giving us 2 to the a, all 2 to the a. So I'm going to put this a inside. I get 2 to the a is multiplied by a to the a, all is raised to the power 2, like this. moreover, consequently, let's set this one equals z. So the equation is become in the terms of z now. So I get here z square plus number 1 equals p to the n. Okay. Now here is the thing. If we take a look at, obviously z square plus number 1 is non-factorable polynomial, which means this one is going to take the whole thing, because right hand side of this equation is the power of p to the n. There is nothing else you can take the value of z squared plus number 1 except p to the n. But another thing, you might say, what about the exponent? You cannot build any exponent here, since we have this polynomial is not going to be factorized. Okay, so like stand still, this one is not moving at all, is not changing at all. So which means you are going to take z squared plus number 1 is equals p to the n. So with exponent n equals 1, if you put any exponent above number 1, you will have also you are going to build exponent from this one in order to get p as a value. If you read this one as an exponent, which means you have an exponent available here which is more than above number 1. You are going to write the general solution for this one. So x equals 2a as we put there, and p equals 2 to the a is multiplied with a to the a, all is a raised number to the, all is a raised number 2 plus number 1 with n equals 1. Okay, so this one is telling us we have infinity many solutions, because as you're replacing the value of a, you get a new solution, you get a new prime. For example, if you take a equals 1, you get p1. This one is given as 2, is given as 5 as you replace a with number 1. If you are going to look for the second solution, for a equals 2, you get p2, replacing a with number 2 here, you get 4. 4 is multiplied by 4, which is 16. 16 squared, which is 256. 256 plus number 1, which is 257. Okay, and so on and so forth. You're never gonna stop. Okay, now let's do this one in elegant way. Let's prove this one in different way. Suppose we have n is not equal to 1. Okay, suppose we have n above number 1. I'm going to break this one into two cases. Case number 1, if n is even, if n is even, which means n is going to be super equal to number 2, like this. Okay, let's set n equals to n. Okay, so I get here z squared plus number 1 equals p to the 2n square, which means I have a perfect square here, p to the m, or is raised to the number 2 as a power. Okay, but I'm going to build an inequality here. So I get here z squared, which is strictly inferior than z squared plus number 1, which equals to this term, which is a perfect square, p to the m, or is raised to number 2 as a power. This one also is strictly inferior than z plus number 1 quaternary square. If I'm going to distribute this one, is given as z squared plus 2 times z plus number 1. Okay, so what do we get here? We get a perfect square between two consecutive squares, which is impossible. This argument follows similarly for the two consecutive integers or two consecutive cubes. So any form writing like this is going to be impossible, because you cannot find, for example, 2 is between number 1 and number 2. We get number 1 and number 2 are consecutive integers. There is a non-integer between those, which is impossible. Okay, this is what happened here for this one. Let's do the second case, case number 2. If n is odd, which means n is going to be super equal to 3. What I'm going to do now, let's take number 2 as a power on both sides here. I get z squared plus number 1 quaternary square, which equals z to the 4th plus 2 times z square plus number 1 equals p to the 2n. Okay, like this. Since n is odd, let's set n equals 2m plus number 1. Let's replace n with that value right there. I get p to the 2 to the m plus number 1 quinary square. This one is the same as p square is multiplied by p to the 2m, all is raised to number 2 as a power, like this. Taking p square out of this one and multiply it by the square of this one. Then dividing both sides by p square. If I'm going to do that, I get here z square plus number 1 over p, all is raised to number 2 as a power, which equals p to the 2m, all is raised to number 2 as a power, like this. As we know, GCD of this one, it could be number p or number 1. Since the right hand side of this equation is an integer, it means the left hand side of this equation must be integer as well. Since p is a prime, which means p divides z square plus number 1, this one is telling us p is going to take z square plus number 1. Okay, if p equals z square plus number 1, which one is telling us it will have a number 1 square, which equals p to the 2m square. Since p to the 2m is a prime, which means p is going to take number 1, which is impossible, which is a contradiction. Okay, none of these cases works, which means n cannot be bigger than number 1, which means n must be take number 1. Okay, if n equals 1, which means p is going to take z square plus number 1 as a solution. Replacing z with its value, I get 2 to the a is multiplied by a to the a, all of 2 plus number 1. Okay, which is exactly the solution that we are looking for. Okay, so I'll end this video. If you have any question or suggestions, just put it in the comment section below. By the way, don't forget to hit the subscribe button and support the channel. And thank you for watching, and enjoy the rest of your day. Bye.